Okay, welcome back. I just want to recap of what you would have missed in the lessons that you've been off. So far we've been working on transistor circuits. Just waiting for this to load up again. So we're working on switch circuits, and then we started looking at this. It's called the potential divider. So what we needed new was under here, you can see it needs a voltmeter, and over here we needed three 470 ohm resistors. So we got this voltmeter here, and I have one somewhere. It's disappeared off here, but you'll see it when I start the practical. And here we have our voltmeter, and it looks like this. So we're going to set it to 20 volts and measure DC voltage. So that's like your battery. It's not going to give out voltage, it's only going to measure things for us. So we set it to DC voltage and click it over to there. We found out our source voltage. We put our source voltage up to the top here, and we connected it all the way in, and then we connected this all the way down to the bottom of the 0 volt. So basically this is now in line with this power wire, and this is now in line with this power wire here. And what's going to happen here is that we're going to just be able to tell the power supply that we've got. Now the power supply we're using is around about a 5 volt power supply. So it should come out at around about 5 volts. It shouldn't come out any more than that, we hope. So what we want to do is recall information about the components, the resistors and the LEDs, learn how to use a multimeter and find about this thing potential difference. So we started trying to build out this circuit. Well, we did, but you weren't here. So we started trying to talk about how we'd put it together in this diagram. So we have this power supply goes on X4 and Y4. Well, this is our X rail, this is our Y rail. So we can see X4 goes on there. I'm just going to move my head out of the way for you. Hopefully. There we are. And there. So we've got it on X4, 1, 2, 3, 4 across, and Y, 1, 2, 3, 4 across. We also then says R1, 470 ohms, yellow, purple, brown to X10 and B10. So X on the top, 10, so we just put it in the X rail there, and B, that'll be down there because that's the B rail. So that's got those bits sorted, and then I would have left you to design this yourself. As I said, that's there. And here comes our resistor, which will come into X10 and B10. So it's down there in B10, down there in X10. You would have then made this circuit, okay? So I would have given you 5 minutes. So let's look at where we come up to. The next resistor we would have got is an R2, a 470 ohms yellow, purple, brown, and this is going to change in this experiment, you'll see, to E10 and Y10. E10 is at the bottom here, but still connected with this other 470 ohm resistor. Down here, as you can see, this resistor is now connected all the way down to the bottom to the 0 volt rail, so that's connected in. We're then going to need a link wire. So our link wire goes between a link wire of any colour, because colour of wire does not matter. It's just a piece of metal with plastic coating over the top. The colour itself won't matter for you when you're building your circuit, so you know what's an input, what's an output, but it doesn't really matter in this case. It's going to go to D10 and D21. So here's D10, here's D21, and as you can see here, we've got our 2 resistors that are between there. Here's our bit coming off down to our LED, and so we've got 1, 2, and then this is the wire here going on to our LED, because what you'll see here is our LED comes in at the end of this wire. So that's why we've got 1, 2, and 3. The dot's going to show we've got 3 things. 1, 2, 3. That connects into our LED, so there's no dots, there's just 2, so these 2 are in line, so this has got a friend here. And it jumps all the way across to F21, well F21 is down here. We then put our resistor R3, which is just going to protect our LED at the bottom, into I21 and Y21. Here's I21, here's Y21. Then we're going to add our red voltmeter lead. So we're going to get a voltmeter and we're going to add our red one into, and this will give us our voltage out. What's going to happen is current is going to do something, current voltage will do something in the circuit, something will happen, it will split, some of it will go this way and some of it will go down here. It will turn on its LED, we're going to find a voltage out there, but obviously we need to measure it against the 0 volts as well, so we're going to put this down to the bottom. and we need to obviously build this circuit. So this will be our voltage in. This will always measure voltage in because this is a source voltage in there. Our black probe is always going to sit down the bottom because that's on 0 volts, and this is going to be our voltage out that we're going to change. So in the practical, you're just about to see R1 is up at the top here, R2 is down the bottom, and we're going to change this. And the LED is going to change in brightness. This is going to just protect the LED, and you're going to see I'm going to move my voltmeter from measuring source voltage to 0 voltage down there, and we're going to go through it. So that's the first thing you're going to see. Okay, I'll see you when we start the practical. So we can see my setup we've got over here. So what I'm going to do is just turn my voltmeter. So it's saying 20, so it's going to measure 20 volts DC. And we'll notice that these probes won't go in the board. So we need to do something about that. We need to wrap some wire around them so they will go in the board. So what I'm going to do is I'm just going to get some wire. And I'm going to stupidly strip one end. So we've got quite a lot coming off that side. And I'm going to sensibly strip the other end. I'm going to do that twice. There are two different colours. So again, stupidly strip one end, sensibly strip the other end. What do I do now? Well, I'm going to put this blue one around the black wire. I'm going to hold on to it. I'm going to just twist it round there like that. I'm going to place that down on the negative, the black one there. Next, I'm going to do the same with the brown. And I'm going to take my long stripped wire and wrap it round there. And place it up into the top and see my meter's reading out 4.99, so near enough to 5 volts. We then need to start building that circuit. So we had a 470 ohm resistor there. We had another 470 ohm that went in line with it and all the way down to the bottom. Like that. And this is the one that we're going to change. We then took a wire, so I use one of these nice jumper cables here, and connect into there and over to there. Next, we had our LED. Our LED goes in line there, and our negative side is pointing down to the negative, and we just place a resistor in. One, so it's got a friend, so it's touching, so it's got a circuit, so it connects up, and two, because we need to protect that LED from too high currents. As you can see, it's on there. Now our meter hasn't changed. That's because we're not measuring any voltage there, we're just measuring source voltage, which is up here. So if I put that now in line there, we see our voltage out from this circuit is 2.24, so that's nearly half of it. Not quite half, but nearly half. Now I'm going to take that first resistor out. Jumps up a bit, but that's because the circuit is not really how we want it. It doesn't have the potential divider of these two resistors. Going to place it in down the bottom, and there. Now notice now, voltage now just jumped up 2.73. So we'll remove the 1K and add one that's double it and a bit more, and put in a 2K2, 2200. So put that in, put it down the bottom. You see it's jumped up again. But what's happened with source voltage? It's exactly the same, because our voltage to the circuit hasn't changed, but as we change this resistor here, what's happening is more electricity is going out that way. We're now going to try our 10K resistor. And then 3.31 ohms is going to, 3.31 volts is going through there, so it's increasing again. We'll then increase the resistance yet again. Seems to have stayed static on that one. And I'm going to put nearly, I'm going to put 500,000 ohms. We're going to see what it's going to go like with that there, 500,000 ohms. I'm going to stay on as maximum it can go to. Why? Because the power doesn't want to go up too much to blow up this LED here, the way it's forcing it. So that's why we get that, it's going to have protection. But notice, as we change this with resistor, what's going to happen here is the LED's got brighter and we've got more power to it. Okay, that's the great thing of what we've got there. So the LED's got brighter, we've got more power to it. I'll explain why changing this resistor, this R2 resistor, is going to change this and why electricians want to go that way than going down that way. Okay, so after that part of the practical, what we would have worked out is the following when it loads up. So what should happen to the voltage when R2 increases in value? We're going to find out that it's going to go higher. So reason why, electricity is lazy. So what's going to happen is going to go through R1, as you can see on this diagram. And it's got a choice, go to the V or go down to R2. The bigger we make R2, the more it's going to resist electricity and it's going to go out the other way. So it's going to prefer to go that way than just go straight down. So the bigger we make that resistor, the more electricity is going to want to go this way than it wants to go straight down to 0 volts, because electricity will take the path of least resistance. And that's why you saw the LED get brighter as we changed those resistors there. So that's great. So what we're going to look at this lesson. So this would have been your lesson today. We want you to create a breadboard layout. So this is a homework sheet I would have given you. This is the homework I am giving you. And if you lose the sheet, you can get a copy on Classroom. It's on there. There's also an extension on Classroom. Ignore that at the moment. And if you've got a choice of how you do this, I'll talk about it when I'm doing it. You can either do it on Pebble, you can do it by hand and actually print off the sheet yourself and bring it in. Print off the sheet yourself, complete it, as you'll see I'm doing, or use another software that you may have been using already for this transistor for drawing breadboards. If you don't have a printer at home, obviously you can print at school in some parts at the moment, not quite sure where, but as I've said on the Classroom, there are a set of these next to my radiator, so you can just get one if you need it, if you cannot print off. So this here, I'm not going to say what is it, this is our Year 7 circuit. So this is our entire Year 7 circuit that you would have built, which seems so long ago. So this is it. So what we've got now is we've got our power wires coming into the top there. We've got our 0 volt rail on the bottom. So this is our battery snap red, battery snap black. Just bring it over here. This is our battery snap red, battery snap black, and this is our battery snap here. The next thing we've got here is this 1K resistor. This 1K resistor comes off a probe wire. So we've got our blue probe down here into the 1K resistor. The 1K resistor goes into the transistor there. So that goes in what's called the base of the transistor. Mr. Evans may have had another name for it. We've got this probe wire here that just comes off the power rail. This probe wire here that just comes off the power rail down there and it comes through. Now, we have got as well our transistor. It's got a collector, base and emitter. This is why it's slightly different. We put our LED through our emitter and our resistor into our collector here. So let's just bring it over into here. What we can see is we've got our LED with a resistor protecting that resistor protecting that LED as it goes into the collector. We've just got a wire going straight down to the base and 2 probe wires to touch together. Now what you knew from Year 7 was if you just held on to those 2 wires, electricity will flow through your body all the way through you and come out the other end, and it will be enough to power that transistor. That transistor acts as a switch, the switch turns on and the LED should turn on, all just by holding on to them. If you haven't drank much water in the day, you'll find that obviously the LED will be a bit dim. If you found hernias like that and held on to it, it will be really, really bright because now you're moist, which will mean you're more conductive than you were beforehand. So, what we're going to need for this is 1 breadboard, red and black power wires, an LED, this new transistor, 3 bits of wire, and 2 resistors we've had previously. So, I'm going to build this on the breadboard and you're going to see it there. Right, so I'm back with my breadboard, and again we've got positive on the top, negative on the bottom. So in our Year 7 game we had a bit of wire. And we held on to that bit of wire. And that turned on the LED when we held on to 2 bits of wire. So we're going to use these as our 2 probes. So what we had as well on that diagram is we had a 1K going into the base of the transistor. And notice I put these anywhere because there's nothing in this section here. So I'm just going to place my 1K in there. This needs to go to the base of the transistor. Now this is my transistor. It's got 3 legs, a collector, a base and an emitter. If you turn it round, it's going to go emitter, base and collector. So what I'm just going to do at the moment is I'm just going to place it straight into the board. Everything in a different column so they're not conducting the same way. And it wants to go in the board. There we are, it's in. Now the end of this resistor's got to protect the base from too big a current. So I need to place that into the board like that. If I'm to hold onto these 2 wires here, okay, what will happen is my LED will start to glow. But I've not got an LED in yet. So I'm going to place my LED in. Flat side is going to point down to 0 volts. I'm going to place that in. Flat side in and in. So now I want to then get my resistor that's going to protect my LED. So we're going to use a 470 ohm again. Just going to place it in line. The problem is it's got to go in line with the collector that's over here, and the nearest one's the emitter. That's easily solved if I take it out and turn it round. I don't have to turn it round, but it's just easier. Just need to check that these 2, the base is still in line with this 1K resistor, which it is. So now my collector can be connected to my LED. And if we hold on to the wire, we'll notice nothing happens because this leg is all by itself. Our emitter needs to go down to the bottom. So using a nice jump wire again, just place that in and place it down to there. What we should find if we hold on to this and hold on to this, the LED lights up. It might not come out on camera, but it lights up even brighter if I do that. That's with me licking my fingers. And now if I touch the 2 together, it should be brighter still. You might not see that on camera. So that's how we've done it. But everything has a friend. So these 2 are connected. These 3 are connected on there. We've got 2 connected there, 2 connected there, 2 connected there, 2 connected there. So everything is connected to something else. Okay, everything is connected to something else. And that's the main point that we're going to do here. Everything being connected. Here's our circuit. Here's our breadboard, here's our circuit. Up at the top here, it talks about its collector, base and emitter on this transistor. We've got our LED, our 470 ohm resistor, our base collector emitter of our transistor, which we know where they are because it says so on there. We've got a probe 1 and probe 2. So we've got all of them connected there. First thing I'm going to do, I'm going to show you how to do it with colours, and then for those of you who don't have colours, just show you how to do it with pens. Okay, a simple pen to get this design. Colours aren't needed, it just might be helpful. First thing I'm going to do is I'm going to colour in the top rail. Now that's my positive. Now every single circuit we've had is like that. I'm just going to put a dot and come off there and write 5 volts. That's done. Next, I'm going to colour the bottom in. I'm going to put a dot and write 0 volts. So that's my black wire. And if I had a black pen, I would have used it. So we can see, when I colour something in, we can see where things are connected to. So this here is my probe 1. That's connected to the top rail. Top rail's up here, so it can go in any one of these holes. It doesn't matter. I'm going to put it there and write probe 1. That doesn't, the end doesn't connect to anything, because remember it's the one that we hold with our fingers. So I'm now going to draw this as probe 2. This is probe 2. You can literally take your pen and drop it. I'm going to put it down there. And right, that is probe 2. Because it's now connected in that line in the board. It didn't connect anything over here, so there's our probe done. Take the next one. I'm going to colour it in. It's orange, and there's our resistor. I know that my resistor has got to connect there, 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 or there. It's got to connect to one of those. Okay, it doesn't matter which one of those it's going to be. I've drawn that anyway, but it doesn't matter. So that's going to connect to our transistor. Now, our transistor is the brains of the circuit, so I can put that anywhere. I'm just going to place it here. Dot, 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 there, 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 there. It's got to go to the base. The base is the middle one. So I'm just going to put a dot by the base. And then there, 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 or there. Put a dot there. And that's connected in. Right. Now, we know that this is our base. This could be our collector. This could be our collector. It doesn't matter. The way I've drawn it, probably this one is going to be our collector, so I'm just going to put a C there. And then this one's going to be our E, our emitter. So all we do is just go through and colour. I'm going to colour my resistor in green, so we can see it. And I'm going to colour my LED in yellow. So, the LED has got to be on the top. It can be anywhere on the top. Might as well put it in line with my C over here. So all I've got to do is just put a dot. There's the top of it. My resistor connects to the collector. There, 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 or there. Well, I might as well go nearer to the top because my LED is up over here. So I'm just going to put a dot. Choose from where you want it to join. I think row 10 is screaming out to me, so I'm going to have that there. So I'm just going to put a dot there and put the resistor in. That's now said the LED has got to go in row 10 there. And we're going to draw that exactly as you would do an LED, with our flat side being this side here. So we now know. So we'll just check, has everything got a friend? 3 friends there, 2 friends there, 2 friends there, 2 friends there, 2 friends there. Oh, what about this one? Well, we can see I've not done it because the emitter is missing being coloured in. Well, that's fine. What we'll do is we'll just take this red colour here. It can go there, there, or there, and it's got to go down to the bottom. So we just put a dot there and go down to the bottom. So again, really simple, really easy. So you may not have any colours at home, and you may prefer to obviously do it with a pen, or you've got one of those multicolour click ones you can do it with as well. Again, same process applies. So we've got our 5 volt rail. Just going to put a dot on the top, doing that, and about 5 volts. Just a bit of a line so I know I've done it. I've got my 0 volts here. Dot on the 0 volts, right, 0 volts, and just do a line like that. I've said before that the brains of the circuit is this transistor. So maybe it might be best to put that transistor in. I'll put that transistor over here. Actually, I'm going to have it the other way around. So there's my transistor. And so now I'm going to have my base there, and my collector here, and my emitter here. So I can put a line through. That's done. What next do we need in there? Well, you can go any way about it. There's no logical way as long as everything's been crossed out. So we can go back to this probe wire and say, well, do we want to put that probe wire in? Might as well put it on the top. Probe 1. Let's do this LED. The LED's got to be near to the collector. Well, here's my collector. So if I put my LED in right in the corner there, there's my LED. That's done. I now know that this has got to connect to the C. The C is there and the LED is there. So I've got to put a dot there and a dot there and join them up with a resistor. Put a line through, it's done. Right, so my E, my emitter goes down to the bottom. There's my E. Put a dot, bring it right down to the bottom. So all I'm missing now is a resistor and this probe wire. Well, the resistor's got to go along with the base. So there, or there. So I'm just going to put a dot there. I'm going to take it away from this mucky area, this bit that's getting filled up, and put it somewhere around here. I'm going to just place it there. And so I'm just going to draw a resistor and connect the two up. Done. And now here's my probe wire. There's my probe wire. Probe 2. And it's done. Everything 2, 2, 2, 2, 2, 2, 2. Everything seems to have a friend there, okay? So everything's connected. There is no problems. So, on your homework, what I want you to do is I want you to have your transistor here. I want it to be so what I want is I want our transistor to be in the D rail. I want it to be here, here and here. And I want our collector to be over here, our base to be here and our emitter to be there. So the collector to be in D10, the base to be in D9 and the emitter to be in D8. Okay, you can draw it as a transistor quite happily, like that. There is our transistor. It's going to be that way around, E, B, C. And the information on that transistor is there, so I've got it the wrong way. I've got it in reverse of what it would be. I want you to then turn this circuit into this diagram here, but only having your transistor sat there.